So this is version B, and it's starting with section A, which is building a rockery. We're starting with this section each time, realistically, because it's the thing that will come up first in the exam. So, if we start off by drawing the activity network, we've got our first one at A, and so it's going to need its little box around it, and A takes 1 to do. Then looking at B, B has no predecessors, so it's not waiting for anything, and it takes 1 to do. Then C, also nothing before it, but looking down, we've got this one down here as well with no predecessors, so we can't fill up the whole page. So C has a duration of 2. D, bringing the topsoil to site, has to wait for B and has a duration of 2. So D is going to actually have to come out of B, and it has a duration of 2. E is going to come out of C, although it's not important for these to be neatly drawn with a ruler. Actually, if you've got one, a much more sensible thing to do with it is to mark where you're at. So, coming for F, F is going to come out of E, and F is going to take 2. G, fitting our fountain, is going to come out of F, and G takes 1. Digging your trench and laying your cable, H is coming out of G. It's going to take 2. I is going to come out of H. And I has a length of 1. J comes out of I. And J has a length of 1. Now K comes out of both A and F. So it's going to have to be further along our page than F and A. So if we put K about here, then it can have come from both F and A, and K takes 2. Okay. L comes out of K and doesn't have anything else with it. That is going to take 4 to do. Then we've got M, and M has to wait for both D and K, so we can put M further along than both D and K, and that's going to take 2 coming out of D and K. Now N doesn't have any predecessors, so N goes all the way back at the beginning because it can happen at any time after we've started, and that's going to take 1. O has to wait for both M and N, so we're going to have to connect O both to M and N. So if we put O down here, it's going to take 2, and it needs to be connected for both N and M. P, filling up the pond, we need for both J and L. And P takes 1, and then the cleanup. So when we clean up, we are going to need Q, and we've got P and O that go into it, and the cleanup is going to take 1. If we had more than one box left at the end that wasn't joined up, we would definitely need an end, but as it is, we are probably okay. So that is our first 3 marks. We are then going to have to do the start times for our activity. So the start time is the time when you are okay to go. So a start time initially, if you don't have to wait for anything, will be 0. So if we look at D next, if you can start at 0 and it takes 1, the time that the next person can start is going to be 1. If you can start at 0 and it will take you 2, the time that you can hand on to your next person will be 2. So with F, E starts at 2 and takes 3, so they'll be able to hand over at 2 plus 3 is 5. Then we're on to some of the slightly more complicated ones. So this one is K, and K has to wait for F and A. So A is ready to hand over, 0 and 1 will be at 1, but F, they're not ready to hand over till 5 and 2 at 7. So you have to wait until both are okay to go. So this is going to come in at 7. In the same way, M has to wait for D. D can hand over at 3. K is going to have to wait for 2 and 7. So they're going to have to wait until 9 before they can actually start. And the same for L, because it's the same 7 and 2. So coming across the top, we've got 5 and 2 is 7, 7 and 1 is 8, 8 and 2 is 10, 10 and 1 is 11. And then we're on to these ones. So 11 and 1 is 12. So they're ready to hand over at 12. 9 and 4 is 13. So P has to wait for the bigger one, the 13, to be able to start. Then down here, we've got N going 0 plus 1. So they can hand over at 1. But M, it can't hand over until 11. So O has to wait to 11 to start. So here we've got 13 and 1 is 14, 11 and 2. So we're going to have to wait for 14. So Q would hand over. So effectively our end is going to be at 15. So going backwards with our deadlines, our deadline for Q is 15. So the deadline that Q would set its people They would want their work ready to start at 15, take away 1. So at 14 and at 14. O would hand a deadline forward of 12, take 2. So they would hand a deadline of 12 and 12. This 14, take away 1, they're going to hand forward a deadline of 13. So if we go along the top, then that's going to be the easiest bit to do first off. So 13 take 1 is 12, 12 take 1 is 11, 11 take 2 is 9. Now at K, you've got two options. You've got one deadline coming from M that is 12 take 2, so you have a deadline from them of 10, but you've also got a deadline of 13 take 4. So we are going to need the earliest deadline, because if we finished the work at 9, it's not a problem. They just get it a bit earlier than they needed it, whereas if we went for this 10 deadline, then L would be running late. So we've got a deadline of 10 in here. 10 minus 2 is 8. So from here, we've got 9 take away 2 is 7. So this one's going to be 7. And the deadline going into this one is 7. 9 take 1 is 8. So we've got two deadlines going in and we need to choose the earliest. 7 take 2 is 5 and 5 take 3 is 2. So that does for part C of the question of the latest finish times. And we're now looking at the critical activities. So the critical activities are the ones where the maths works. So 0 plus 2 is 2. So this one will be critical. 2 plus 3 is 5. This one will be critical. 5 plus 2 is 7. This one will be critical. Then we get to a junction. So 7 plus 1 is not 9. So this one's not going to be critical, which means we don't need to check these ones. Then if we start here again, 0 plus 1 isn't 7, so that's not going to be critical. 0 plus 1 isn't 8, and 0 plus 1 isn't 12. So here, 7 plus 2 is 9, so K is going to be critical. Then we've got two ways we could go from here. 9 plus 4 is 13, or 9 plus 2 is 12. So L's going to be critical, but M isn't. 13 plus 1 is 14, so this one's critical. 14 plus 1 is 15, so this one's going to be critical. So our critical activities were C, then E, then F, not G, but went down to K, along to L, and then P and Q. And it took us 15 to get to the end. So if we're looking in hours here, that would be 15 hours. The last question that we're asked about is the float at D. So if we find D, that's this one here. Our float time is how much spare time we've got. So if we start at the beginning and the work is going to take us 2, then the total time we need is up to 3. But we've got up until 10. So the spare time that we're going to have will be our deadline take off the time we need, gives us our spare time. So we have a float of 7 hours. This is the second section on version B, and we are looking at Florence. So we're asked to use Dijkstra's algorithm to find the shortest time from GA to PP. So we are going from GA at the top down to PP at the bottom. It tells us to show all temporary labels. This means they want to be able to read the things that you've crossed out and the corresponding route at the end. So Dijkstra's is going to be all about the boxes. So we start off at GA, so it takes us no time to get there. And then we get into the algorithm. So box the smallest number that you've written, and then one step in each direction. So 0 and 15, 0 and 14, 0 and 10. So you've got one step in each of these directions. Box the smallest number that you've written, and one step in each direction. So 10 and 6, and 10 and 9 is 19. 10 and 8 is 18, but we've already got 14, which is a better option, so we'll keep that. Box the smallest one we've got is 14. 14 and 1 is 15, which is the same. 14 and 8 is bigger. 14 and 7 is bigger. 14 and 9 is 23. Travelling salesman on Florence. So first off, we are using the nearest neighbour algorithm. So we're looking at going to the closest place each time and then going home. And we are starting at LB. So nearest neighbour algorithm, the only thing that's important is what's closest at that time. So first off, if we look at LB, the closest thing is going to be BA. So yeah, we've got enough space there. So that is question 4, part A. We start at LB and it's going to take us 8 to get to BA. So we then need to look down BA and it's going to take us 1 to get to MF. Then looking down MF, we can't go back to BA because we've already been here. So we're going to have to go on to BP. So MF heading to BP, and that was 8. So looking at BP, smallest one's 3. So it's going to take us 3 to get to PA. Then from PA, the smallest thing we've got is 7. So it's going to take 7 to UG. UG is 3 to PO. PO, already been to UG. So going to PP, and that's 4. PP, already been to PO, so we'll go to SS, and SS is 5. So once we've got to SS, the only place we've got to go that we've not already been is SP. So that's going to have to go up to SP, and that's going to be 10. So the last thing we've got to do is we have to go back to where we started, which was LB. So to go from SP to LB, we are looking at 9. So in total, we've got a length there of 58. So table 2, we have been asked to use Prim's algorithm, and we are finding a tree, so it doesn't need to go back on itself. So for table 2, if we start in the first column, this is going to be the place we start, so I'll put a 1 just above it, and we can highlight this column. So we can choose anything from our highlighted column. So smallest thing is going to be this one. So we've got B, A, and that went to M, F, and that was 1. It is important that you number them, and it is also important that you cross out your row once you've got something from there. So we chose MF, so MF is going to be 2, because that's the second place we know about. We started off at BA, so we don't need to worry about that one either. So the smallest thing that we've got here is actually still in that same first column. We can take that 7. So we've got BA to SP, and that is 7. So SP is going to be the third one that we've got. So we don't need to go back there, and we can highlight it because we know all about it. So from here, we can still check these. Smallest one over here is 8, but over here we've got this 6. So that gives us SP going to PO, which is 6. So we can now cross out PO. PO was the 4th place chosen, and we can highlight PO. Looking for the smallest one, which will be this 3. So we've got PO to UG is 3. So UG was our 5th one chosen. We don't need to go back there, and we've been there, so we know about it. The next smallest one is this 4, because these 3s haven't been highlighted yet, so we can't use them, and we don't have to use the column we've just come from, so we can go back to an earlier one. So we've got PO going to PP, which is 4. So PP is going to be the 6th one chosen. We can cross out PP, and we know about what's there. So now we've got some 5s. And these 5s actually both take us to the same place, so it doesn't matter which one we choose. So if we go for this one, we've got PO goes to SS, and that's 5, and that's the 7th place chosen. We aren't going to need to go back there, and we do know all about it. So we've got left with 9 and 8, 7, 8, 9 and 13. So we'll come back right the way back to this 7. So we've got UG going to PA is 7. So PA will be the 8th place to be chosen. Don't need to go there again. And then we've now finally got this 3. So this 3 is going to be the smallest. So we've got BA goes to BP, and that is 3. So BP would be our 9th place chosen. They will condone it if you don't write in that 9. But it's useful to do because then you know you've got everything written down there. And you've just got that a little bit neater. So we've got our list. And it's good practice to also draw the tree. So what we've got is we've got BA, and that went to F. We've got BA that went to SP. We've got SP that went to PO. We've got PO that went to UG. But we've also got PO goes to PP. And PO goes to SS. UG goes to PA. And then right back using the first one, BA goes to BP. No, that's not true. Can't read my writing. PA goes to BP. So adding those all up, we should hopefully get a minimum spanning tree of 36. So we've got a length of 36 from our minimum spanning tree. Our next bit of the question says hence. Now hence is examiner speak for you've done something, now use it. And we want to find a lower bound. So we're looking for a lower bound for the tour. So to find a lower bound, we are going to have to notice that out of these ones, there is one missing, and the one missing is LB. So we have LB goes to the shortest one it can go to, which is BA, and that is 8. And then the other one is going to be 9, and it could be either of these. So 8 plus 9 is 17. And then to find the lower bound, we need the length of our minimum spanning tree. So we'll then have 17 plus 36, which should give us a lower bound at 53. This last section is incredibly regular. So given the minimum time is T, use your answer to do the smallest interval. So what we're asking for here is your lower bound. So for part C, you want your lower bound, which you've just found. We know that the tour is T, and we've got an upper bound from part A, and that was 58. So we know that T lies somewhere between these two things. So we're going to have to put in the inequalities, and the small end of the inequality goes with the smaller numbers, and the big end goes towards the bigger numbers. So the total for everything is 150. So our Chinese postman problem comes in at 176 minutes. So we're then looking at the fact that we don't have to start and finish in the same place. So if we don't have to start and finish in the same place, then we're going to be looking on here for our smallest bit. So the smallest thing that we've got is this 10, and that represents repeating this section. So what we can do is we know that our start is going to be at the Galleria. Our finish is going to be at MN, and we will repeat as 10. So this time our Chinese postman problem is going to be our repeat plus our total, which comes to 160. So we are still in Florence, and Brian is taking a tour group around Florence. So things that we know. He wishes to collect and leave his tour group at the Galleria. So that is the same. So same start and finish. And we need to use Chinese postman.